Welcome to our webinar on database interaction for the simulation of electrical networks. Thank you for joining us, and we're excited to share with you some ideas on interoperability concepts. My name is Gabriela Andrade, and I am a marketing specialist here at GERS. I will be giving a brief introduction, followed by the more technical side of the presentation presented by Mr. Leniker Palacios. Please submit any questions you have, and we'll read them at the end of the presentation. All right, to begin, I'll give a brief introduction on our company, GERS. GERS is an electrical engineering consulting group that was established in 1981. To date, we have completed over 6,500 engineering projects and over 3,700 electrical studies in over 45 countries. On this next slide, you can see the countries where we have carried out projects from our offices. We have offices currently in the United States, Mexico, Colombia, and Chile. And to date, our portfolio covers many consulting services, products representations, research development, and innovation. So for this presentation, we will be accompanied by the engineer Leniker Palacios, the Director of Power Systems Analysis Tools here at GERS. He will be presenting information, especially from an electrical engineering perspective, focusing on how power system analysis tools can help with energy transitions where the network automation is significant. We will now begin with the technical side of this presentation. Welcome, Leniker. You may now begin.
Thank you very much, Gabriela. Good afternoon to all attendees. So I am glad to present this new topic about the interoperability in order to increment the capabilities about the power system analysis tool that we could approach in order to integrate new developments on real-time simulations. So first, to present here the content of this presentation, I would like to remind you some of the developments that we presented before. Maybe you remember the attendees that participated in our webinar about microgrids automation that we developed an SCADA system where we added here an optimal power flow solution based on the Neplan engine calculation, and it allowed to implement here how the energy management system could be approached in order to reduce the losses or even the optimization of the cost. However, in this presentation that you can check in our YouTube channel, that you can check in our portfolio, this was focused about how was the integration. I mean, today there are many ways it's coming from different systems. Well, for this presentation, we are going to focus on that. Initially, we are going to present an introduction. We are going to do some fundamentals of interoperability, use of this concept for power grid management, interface development concept, common information model. It is now CIM, the shape files and its integration with the GIS, and finally some conclusions. Based on this, what I'm going to do here is present here some about the fourth revolution that is now the industry 4.0 or 4.0. Basically, it has different pillars, and some of them are based on cloud computing. Some of them are also based on the Internet of Things, system integration, that is one of the focus on this presentation, simulation, big data. And what we are going to see here is that we are covering most of this pillar with a solution that is the power system analysis of Neplan, where basically this is the first solution that was implemented with all capabilities for using the web services. Now, we only added here a sign that represents that will be the only thing that is not being covered by Neplan for all the pillars for industry, the fourth revolution. For each one of the another applications, we will be finding some equivalents of this solution. Well, when we speak about the interoperability, we are going to present here one of the focus, or maybe why do we need to integrate these kind of systems. For example, we can see here that we could be using some simulation, and this simulation is using the database of the system for the simulation, and it would be according to the purpose of the simulation, maybe for a steady state condition, maybe for transient analysis, maybe for arc class analysis, short circuit calculation of current protection. There are a lot of possibilities that you can use. However, you can use historical profiles, or you can use measurement in real-time data. So if we would like to focus in this kind of application, we need to integrate in real time the source of this information. So it opens the interoperability concept, because in this concept, we will be doing different ways to approach the information. So some years ago, we thought that it maybe was not possible to simulate in real time, since the parallel computer was not enough using the hardware that they didn't allow it to do it. However, today we have many technologies to use that, and even the cloud computing capabilities that NIPLAN offers can approach that. Okay, but it depends on the purpose. But the challenges regarding the requirements on the parallel computer are using with this solution. Also, we are able to represent dynamic and load of measurements, and it depends. Why would you like to do this approach? You will be able to check the limits violation, results of the element, some histograms, or would you like to do a state estimation in order to do some analysis previously to take decisions on the network operation? Let me show you a little example. I have here a network, and maybe some of you know this network. This is the IEEE 123 node network. And this is a distribution network where the system is asymmetrical. You have an asymmetrical network. So for this system, I added here a measurement device. So I ran before to use the measurement device a power flow solution. And we are finding here that we are getting the results of the current for each phase, for the phase A, B, C, and we are having here an asymmetrical result. However, this result is based on the planning of the network. I mean, it was obtained this simulation because on the loads, we are getting the information that we added manually. But if we would like to do real-time simulation, we could approach this kind of systems. What will happen if we will be getting here a balance system here that maybe we will be getting here 200 per phase? And what could we do if we would like to approach this result based on the measurement? So for this, it is now some concept. We are getting here the NIPLAN load estimation. In SCADA systems, we can see how the concept like the state estimator systems are being approached in the information that is coming from the real life information, maybe from the SCADA system, maybe from the AEMI, maybe from the EMS system. They are different sources of information that we could approach in order to simulate the network based on real conditions. And it will allow to implement the state estimator, and based on that, you can do any analysis in order to detect what will be the impact of this variation in order to detect previously if that will be a good impact or that will impact negatively. Well, if I enable here, we will be getting here the information such as the information is coming from the measurement device. Now we can see here, we are getting 200 per phase that is according to the measurement. And in this case, what the software did was to apply a scaling factor for each load, but if the load allows that. We have per load a load balancing capability that offers this possibility. If we uncheck here, the load won't be modified. But if we check here, the load will be affected. This is the purpose of this. Because even that doesn't necessarily will be a balanced system. Maybe I could have here a system, an unbalanced system that also will be affected with this measurement. Now the question will be, okay, but how can we integrate these measurements? Because I am adding them manually, and it opens the different possibilities that we could approach. Starting that, I would like to present here some fundamentals of interoperability. I like to show a lot this architecture because this architecture presents the more convenient concept to approach this topic. What do I mean? We can see that we can increase the level, and starting here, we get how could we have an interoperability on the substation where the IED devices are able to communicate between them, and it allows to implement some automation schemes based on the information of them. To date, it is now, for example, application-based is the IEC 6150, and it has allowed to implement many applications like the digital substations. However, if we are increasing the level, we can see here how in a high level we can implement another type of application where the time step between the information is coming maybe not in a real time in microseconds here. Maybe here we are getting information in step times, but maybe that is coming from the power information. Maybe we are getting information regarding the RMS measurements, and they are being sent into the reports. And we are getting here the IEC 6150, but through another message like the MMS protocol. And it is very interesting to notice here that we are getting this level where the SCADA systems, the EMS system, DMS system are used. And to date, many of these applications are operating the electrical networks. But it is very interesting to notice here that high level, we can find here the common information model. And it offers that if this layer is on top level, this layer will be covering the information that is coming from different sources. And here we find the web services. So I like this architecture because this architecture shows that if we are speaking about interoperability, we can check that according to the requirement of the information that we need to share between devices, we will be using the communication protocol. Based on this, I have here a meeting of the interoperability, and I took this concept from this reference because in this reference we are open to take here a meaning very according to the requirements. What do I mean? This reference shows that interoperability is understood as the ability of two systems to exchange and use the information. And it is very interesting to notice here that it means two systems, not two equipments, not two devices, because I could get interoperability between software. I could get interoperability between EMS system, DMS system, SCADA systems, and I can get, of course, interoperability between measurement devices or IEDs. So it depends on the application. Three topics additional here that we can see, and one of the main challenges for the interoperability is even the form that the elements was named. What does it mean? You have two networks. You have two systems, for example, for the same network. Two different database sources. And you have a transformer in each database. And if that is the same transformer, you must find the same short circuit impedance because it is the same transformer. However, since there are two different databases, two different users, maybe the user changed the name. and you will find the same transformer with different name. And that was one of the first challenges, that it was, of course, solved with the common information model, since the information has been standardized. Another thing here is the same example where the short circuit impedance requires data verification and correlation. That should be the same information. Well, if we are going to use this concept on the power grid management, we can increase, okay, we need to model the network. How can we model the network? Where is the information on the network? And we can see some pictures from our projects where we are able to take the coordinates for each asset, and we can take the attributes for each one of them. We can see the location of the loads, and it is noted that this customer is for the oil and gas sector. It is noticed that we can get the information regarding the protection devices, regarding maybe the MCCs, and all of them will get information that we will be approaching for the simulation. But it depends. What would you like to simulate? Would you like to would you like to do analysis in steady state conditions, like the power flow simulation? Or would you like to do dynamic simulation? Or would you like to do arc flash? Or would you like to do short circuit? Because if you require some specific simulation, that will be meaning about what kind of of information do you need. So we are using here some technologies for georeferenciation, and it is noticed that we are using here a GIS system in order to get the information regarding the network equivalent model. Most of the cases we need the nameplate of the asset. And based on the nameplate, we are getting here also a database that we can add in our power system analysis tool. But if we are getting the information from an external system like the GIS, we need to interface the information. Before of the new technologies and before of the concept, I mean the new standard in interoperability, we used some methodologies that allowed to do some mapping. Basically, we will be adding here the specification about what is the meaning of the attribute that is coming from the GIS and the equivalent of the element in the power system analysis tool. And of course, we will be getting the information from the real conditions based on the GIS. Based on that, we create here an external file that we imported here. We are importing here that file, and we will be getting the equivalent information, but in a mathematical model that will be represent the network planning model. We can run the simulation based on the information that is coming from the GIS, but we need to map the information before. And of course, it is now how we can implement applications like Google Earth in order to identify the real location of that. In this example, I am showing here a city, and this city has an information regarding the electrical network. We can find here the location of each node, and we are getting here the information about, okay, this will be our circuit or distribution network, and we will need to simulate this distribution network. How? Okay, how can we approach the information coming from the GIS in order to simulate the network? Another topic is the operation. Since the GIS represent the attributes that are for each asset that can be represented on the information, particular information per asset, I mean, the short circuit impedance of the transformer won't be changing. That is an attribute of the transformer. But maybe the real conditions about the load behavior, the generation dispatch, the topology of the network, that is been changing. So that represents another topic that is related to the operation of the network. And we can see how could we approach different technologies that they are sending information in real time to our SCADA system or EMS system. And it approaches communication protocols. So I am using here, for example, the synchrophasors. And the synchrophasors are using here an standard ANSI 37118. We are getting here the advanced metering infrastructure. I am representing here only of the many communication protocols that we find. Of course, this is not the only one. This is only an illustration that this is one of the methodology that you could use. The IEDs also can approach another communication protocol, and to date, we also now can check here how could we use the new standard. Okay, that standard was is been increasing in the applications, the 61850, for communication between IEDs and between the IEDs with the substation, when we are increasing here the approach using the reports. And as we can see here, all the information is being centralized on the SCADA system. If you remember the architecture that I showed before, maybe in a top level, we can approach web services and the common information model in order to exchange information between them. NIPLAN is in this level. And we can approach two ways using these web services, and even what will happen if we add internally in our SCADA system the calculation engine. Could you do it? Yes, the meaning of this purpose is that you can integrate directly the calculation in your SCADA system. Then you don't need to replicate an equivalent network in the power system analysis tool, since you are running the simulation directly on your application. Regarding this, I am going to focus two ways in order to exchange information, but they are not the only ones. I mean, to date, we can find different methodologies or strategies to exchange information. And one of them is the common information model. And you can find on the reference, I will show you where could you find this reference about the purpose of this strategy. And you can see how the CIM is a model that can represent many objects in the electrical infrastructure. And that could be used for the exchange information between the EMS systems from different manufacturers. And you can exchange information between EMS system and DMS system or different applications. Even you can exchange information between power systems and analysis tools using CIM. For example, the IEC 61970 shows how it was implemented and a standard for common grid model exchange specification that is related to the transmission system operator software. And the application that you can exchange using this standard is based for the load flow and contingency analysis, short circuit calculations, dynamic simulations. And let me show you how it is requested that you are getting here a conformity of this standard, where many vendors or software developers are providing here a certification. We can find here NIPLAN, that this software is according to the common information model layer. We can find here a certification about that, and of course it will specify that it covers the topics. And we can find here different software developers. Some of them are now in the USA, some of them are now in Latin America, some of them are now in Europe. And of course, many applications will be exchanged information between both softwares. And it has allowed that different transmission system operators can exchange their database regarding the electrical networks for different purposes on the simulations. And of course, not only between power system analysis tools, you can exchange the information also with the SCADA systems using the CIM. And this is one of the approaches, because if we are speaking about database integration, we need interoperability. And that must represent the same conditions. And we are not able to get different results if we are using the same information. So we are getting here how different vendors can represent here that they are according with the CIM. And that means if they are here, we can exchange information. So let me show you a little example with a network. I have here a CIM file. The CIM is based in XML protocol. And for each kind of information, we are getting here a specification. We can get here information regarding the diagrams or regarding the graphics, because they can be shared too. Or we can find here information regarding the equipments. I mean, the parameters about the transformers, the transmission lines, and even the loads can be exchanged using the standard. Then, if we use this communication system, we could be getting here how this standard allows that we can implement here. If I use here my CIM interface, I could get information from any system that is showing that has conformity with the common information model. So if I import here this SIM system, it will show me that, okay, we can get here the information, and maybe some of you attend this will know this system. This is the IEEE 14 nodes. And it comes from the SIM. So if I run here a simulation directly using this information, I will get here how the power flow simulation can converge directly. So one of the main focus, because if we are getting information regarding different conformity certifications according to the CIM, we would have this approach that the information regarding the electrical model can be shared between different software developers. Well, so as I told before, we can exchange information regarding the information of the elements. We can exchange information regarding the diagram layout profile, regarding the operation of the system, and even we will be getting here also information regarding the assets management. Another topic that is also used not only for transmission networks, and here we will be having a good approach for distribution networks too, that is the shapefiles technique, where the shapefile allows easier integration with GIS systems. And to date, many GIS systems can provide shapefiles. If you look for shapefile in any GIS provider, you will find that maybe they are able to export the information in shapefile. In this way, if we are able to get the information from the GIS provider using shapefile, that we only will need to do is to map on a first time each element. Maybe in the GIS, a transformer will be called, I don't know, a transformer, and in NIPLAN will be called trans. Maybe we will need to have a mapping between them. And how can we do it? I am getting here an information regarding this is a shapefile, and this shapefile was exported from the GIS, and we can see different files per each type of element. So if we add here a mapping system, We will be given the opportunity to understanding what is the meaning of each one of the files. Maybe, for example, the file that is called trf, we are mapping here as a load. Maybe the file that is called here switch, we are mapping here as a load switch, and each one of them is being mapped. So once I would like to do this information, of course, I won't use the CIM. I will use the importation of the shape files, but we can see that we have many opportunities to get the information from different database sources. So if I add here the opportunity to import this JFile, in this opportunity, I will be getting the information directly from the GIS that is able to export the system. Now the system is being imported to NIPLAN, as we can see here on the progress. And the result that we will be getting here is a georeferenced system according to the information that it was implemented on the original files. Of course, these characteristics will need such, will get as many information as it was implemented on the original GIS. And of course, it must be mapped. So once the importation is done, of course, we will be getting here the equivalent system in our power system analysis tool that maybe I can get here where is the network directly without the map. And of course, this information can be related for any simulation as most as information we are getting from our GIS. And this system is the same that I showed before here in our Google Earth. That is the same. Well, based on that, I have here a video that will represent here how will be the approach of interoperability concept in order to represent how could we use the power system analysis tool directly on the GIS. We are getting here that we can open here our GIS and we can represent here the map. And as we can see here, we are on the city. This user is not doing any modification on the equivalent model in NIPLAN. This user is changing the information from the GIS. And this user is going to plan if this modification will affect or post or not the network operation. So he will get here a result. And this result comes from NIPLAN. And we cannot see the database of NIPLAN in anywhere. What we can see is that we are getting here some results from NIPLAN, but this user is using the GIS. That represents one of the focus of this kind of application, where the real-time simulations or online simulation are one of the main applications that has allowed to solve many challenges regarding the new energy transition, where the renewable sources they are affecting the network operation, since we are not able to dispatch the energy. We must take as much as generation as the energy can provide. Maybe the energy source, maybe like the sun, like the wind. And even if we speak about the electrical vehicles, we are not able to know where this load will be connected and what on how much power will take. So this kind of issues that represents many variations on the electrical network operation can be solved if we are able to have an equivalent network model in order to replicate the real conditions and do a predictive analysis. So today we are speaking about digital twins applications, and they are focused in order to you can follow the real condition and the mathematical condition, and you have a state estimation and predictive analysis. And you can solve this kind of variation that we will be getting on the modern electrical networks. So our proposal is that we have an IT services, and those services is of course for approach many calculation engines that we are able to use, and we will be getting the opportunity to integrate on the real condition on the SCADA system that is being controlling the network. We will be getting the opportunity to integrate calculation engines. So we can see here, we can have development for exchange information with external tools like the GIS, like the SCADA system, like the smart grids applications, protection device management system, and the asset management systems. So that will be to approach about concept that the interoperability is offered today. For finishing this presentation, we have here for conclusion. The first one is that online and real-time simulation have taken advantage of new digital technologies in order to provide network automation solutions. So that is one of the advantages that is offering the modern technologies to us. The new IETs are coming with digital applications that is able to send us the information in real time. So we have the opportunity to use this information. On the second conclusion, since there are many manufacturers and software developers, the interoperability has allowed for the solving of issues regarding database management and communication between them. To date, we have many manufacturers, many developers, but we need the information from them. Today, we can exchange the information and we can use them. And of course, the approach will be what kind of application do you need? Do you need to have a state estimation or predictive analysis based on the purple simulation? Or do you need to run dynamic simulation directly on your SCADA system? It is solving this kind of challenges. Our 10th conclusion, that is our proposal. We are not offering here only licensing supplies. We are offering here IT services that they can complement any licensing supplying scheme. And of course, it has many opportunities where we are able to integrate the calculation engines directly on your energy management system. And finally, we have presented in this webinar how NIPLAN is highly interoperable with any external system, like SCADA, like the EMS, DMS, GIS, and other power system analysis tools. So that was the presentation for today, Gabriela. So I hope it has contributed in different concepts to the attendees in this presentation. And of course, we have some questions that I can solve here. But however, we are presenting here our content information, and we will be getting or we will be answering any question that you can do here, or you can contact us through our social media or our email. Then I could be giving you more information regarding this. I don't know, Gabriela, if we have some questions.
So much for the informative presentation. Now we'll begin with the question and answer portion of the webinar. Again, to all the attendees, if you have any last minute questions, feel free to send them through in the questions. All right, so our first question is, when are the NetPlan integrations to the GIS or SCADA systems required?
Okay, I mean, it depends on what is the purpose of the integration. To date, I have presented how the energy transition has affected the network operation. So for the utilities, for the distribution network operators, they need to solve these kind of issues that is they are being integrating on the modern electrical network. So I mean, we are getting the opportunity to solve all the challenges or this transformation of the networks are are being increasing on the network. So I mean, it depends on the application, but of course we are getting here an opportunity to integrate many calculation engines, and it depends because if the customer is trying to have a management system regarding the operation system and is able to validate the selectivity of the network, of course he has the opportunity to integrate the real settings and compare how that real setting will be affecting the selectivity or not of the network based on the mathematical model. And also application will be okay. We will be approaching the state estimation in order to do predictive analysis. And before I can open any circuit breaker, before I can start a new generation plant, or before even I have a new connection of the load, maybe I could do I could evaluate what will be the impact of that I don't know of that operation before to do that in the real life conditions. So it depends, but in my opinion, of course, if we can integrate the digital twin of the network in order to replicate the real conditions based on the mathematical model, we are getting many capabilities.
Great. Okay. Our next question here is, could you share the presentation or video?
Sure. We have our YouTube channel and our social media, and in general, we are able to share the information through our these channels. And of course, also you can also contact us through our email, and we could give you more information. And it'll be my pleasure to answer any question after this webinar. But yes, we can share the presentation and the video, and even you can check our social media where you are able to find this presentation.
Great. Okay. Our next question is, what is GERS experience in these types of projects?
That is a good question. Since we are a consulting company, we are able to do many projects, and one of them is the IT services. To date, we have experience in some countries in Latin America, like Colombia, like Guatemala, and here in the USA, we have also developed some project in Texas for the oil and gas sector. So the project that we have developed are from the integration of the database coming from the GIS system and the SCADA system in order to have the equivalent network in NIPLAN. So we have developed many interesting project that of course we can give more information regarding this, but of course it offers to us the capability to show that we have the experience for implement this kind of interfaces. And of course the video that I showed was implemented directly for our developers, and they did the application directly doing an integration on the GIS using the NIPLAN engines. So I think we have a good experience of that in different countries.
Okay, great. And we have one last question here. It is it required to acquire a NIPLAN license in order to implement this type of solution on a SCADA system?
I will say that it depends, because if the customer doesn't have any model, I would recommend to create first the model. But the customer has two ways. The customer could use a NIPLAN licensee to the internet or to the local solution, and he can model the network and use the network. But the user can also use the software as a service. And in that way, this customer doesn't need the licensee. He is accessing the software through the web services. That is one way where the user can create the model directly on ePlan. And the another way is I could use the calculation engines. I could use the module instead of licensing. And in that way, we will be using the ePlan API where that will be integrated into the GIS or the SCADA system, and it will use the database in the server. And of course, that needs a good approach of the project of the IT services because, of course, the database should allow to run the simulation using the model. And even I remember I showed a graphic. Let me show you. That is here. It's here. You have two ways. This is the way that I mentioned. You can use the calculation engine directly on the SCADA system. So in this way, you are using the module instead of the licensing, but you have two ways. I would recommend if the customer doesn't have the mathematical model for running the simulation, I would recommend the software as a service if he don't need the licensing. And the software as a service can allow the accessing through the internet. That is like using the email, and you will have your user and password, and you will be accessing through the software. So they will be the suggestion that I could do.
Okay, great. So thank you very much to all of our attendees. This webinar was recorded and will be posted to our YouTube and social media pages. And if you have any questions, feel free to write to the email on our last slide here. And Leineker would be happy to show any solutions or to explain any more of the concepts that we spoke about today. So thank you very much, Leineker, and I hope you all have a good rest of your day. Thank you for attending today.
Okay. Thank you, Gabriela. Thank you for attending.